Dear students, welcome to our lecture series of Calculus 2, and today's topic is hyperbolic functions. This is lecture 6, and the first question is what is a hyperbolic function? A hyperbolic function is a certain combination of e to the power x and e to the power minus x. And we know e to the power x is an exponential function which is increasing function, and e to the power minus x is decreasing function. So the next question is how can we define hyperbolic function mathematically? You see, one can easily write e to the power x equal e to the power x plus e to the power minus x plus e to the power x minus e to the power minus x divided by 2, because here you can cancel e to the power minus x and e to the power minus x. So in the numerator you have 2 e to the power x. So if you cancel 2 and 2, remaining is e to the power x. So we can write it. Now we can separate it by writing e to the power x plus e to the power minus x divided by 2 plus e to the power x minus e to the power minus x divided by 2, and this one is an even function and this one is an odd function, and this one is known as hyperbolic cosine of x plus hyperbolic sine of x. So we understand that sine hyperbolic x equal e to the power x minus e to the power minus x by 2, and cosine hyperbolic x equal e to the power x plus e to the power minus x by 2. So from these two definitions you can define other trigonometric functions like tangent hyperbolic of x equal sine divided by cos. So we will get e to the power x plus e to the power minus x divided by, because this 2 and 2 will cancel, e to the power x plus e to the power minus x, and cotangent hyperbolic of x we can write in brief. In brief we can write cotangent hyperbolic of x equal e to the power x plus e to the power minus x divided by e to the power x minus e to the power minus x. So this one is nothing but the opposite of this fraction, and from here we can, from this one we can write cosec hyperbolic of x is equal 2 divided by e to the power x minus e to the power minus x, and from cosine one we can write second hyperbolic of x equal the just inverse of this fraction, because we know cosine hyperbolic of x equal 1 by sec hyperbolic of x. So the numerator will be 2 and the denominator will be e to the power x plus e to the power minus x. So you see, hyperbolic functions has lots of application in engineering problems and have many properties in common with the trigonometric functions. So you can calculate any angle of hyperbolic sine, cosine, tangent, cotangent, cosec and cosec and sec hyperbolic of x by using these properties. For example, sine hyperbolic of 0 is equal e to the power 0 minus e to the power minus 0 divided by 2, which is equal 1 minus 1 by 2 equal 0. So hyperbolic sine hyperbolic sine of 0 equals 0, and similarly you can calculate hyperbolic cosine of 0 equal by using this definition: e to the power 0 plus e to the power minus 0 divided by 2, which is equal 1 plus 1 divided by 2 is equal 2 divided by 2 equal 1. Let us calculate other one. Hyperbolic sine of 2 is equal e to the power 2 minus e to the power minus 2 divided by 2, and you can easily evaluate it by using your calculator. E to the power 2 minus e to the power minus 2 divided by 2, which will be approximate to 3.6269. So now the next question is, why the functions in these sections are called hyperbolic function? So to answer this question, let us recall the parametric equation x equal cos t, y equal sin t, where t is from 0 to 2 pi, and squaring and adding we can write x square plus y square equal cos square t plus sin square t, and we know cos square t plus sin square t equal 1. So x square plus y square equal to 1. This equation represents a unit circle like this, having center at origin. So it represents a unit circle. The radius is 1. So any point on this curve you can represent by cosine t, sin t. And again, if you just write another parametric equation like x equal hyperbolic cosine of t and y equal hyperbolic sine of t, where t goes to from negative infinity to positive infinity. In this case, if you square and subtract one from another, you will get x square minus y square equal cos hyperbolic square t minus sin hyperbolic square t, which is equal 1. And we will see later that cos hyperbolic square t minus sin hyperbolic square t equal 1. We will prove it later. So here we get x square minus y square is equal to 1, and this equation is the equation of a unit hyperbola. It is like this. It's like so if the radius is 1, then it will make an asymptotic behavior with this line. So the graph of this one is nothing but unique hyperbola. So you see, by just replacing instead of cosine x, if you consider cosine hyperbolic x, and sin x, if you consider sin hyperbolic x, then it gives you a unit hyperbola. And that's the main reason in these sections the functions are called hyperbolic functions. And let us try to graph or sketch hyperbolic function. How can we graph hyperbolic function? First, let us try to graph y equal hyperbolic cosine of x, and we know this one is equal e to the power x by 2 plus e to the power minus x by 2. So hyperbolic cosine of x is nothing but the addition of these two exponential functions. So we know y equal e to the power x by 2 is an increasing function like this. And y equal to e to the power minus x by 2 is a decreasing function. It's a decreasing function like this. And here the coordinate of this point is 0, half, since e to the power x by 2. So now if we add these two functions, then you see when x equal to 0, this function gives us e to the power 0 by 1, it means half, and this one also half. So when x equal to 0, for this one y equal half plus half equal to 1. So this half and this half. So this is the point of y equal to cos hyperbolic x. And for example, when x equal to, let's say, 1, then y will be this one plus this one. So let's say this one, let's say b1, and this one, let's say b2. So b1 plus b2, if you add b1 here, you will get this, you will get a point like here, and for another one, this one and this one. So from here you should add this part, maybe it will be here, and similarly for when x equal to this, b will be like, you need to add it here, so it will be like this, and another point will be here. So the graph of this function will be this blue line. And it will be, these two curve will be just will form a curvilinear asymptote. So you see this graph is e to the power x by 2, and this one e to the power minus x by 2, and this one y equal cos hyperbolic of x. And similarly, and you see the domain of this function will be negative infinity to positive infinity. The domain of cos hyperbolic x will be negative infinity to positive infinity, and the range of this function will be 1 to infinity, and this one should be closed interval, but this infinity should be open interval. And how about y equals sine hyperbolic x? Let us try to graph it. Same way we can graph this function. This one is our x-axis, the vertical axis, y-axis, and sine hyperbolic x is equal e to the power x by 2 minus e to the power minus x by 2. So the graph of e to the power x by 2 will be same like what we draw before, this one, and the coordinate is this point is 0 half, and this one is 0 negative half. So which is the graph of negative e to the power minus x by 2. So this one is the negative e to the power minus x by 2, and this one is the e to the power x by 2. So the graph of hyperbolic sine of x will be just the subtraction of these two functions. You see, when x equal to 0, then you have half for this one, and for this one you have negative half. We can write this one plus minus. So let us just add the two values from these graphs, then it will be half plus negative half. So you will get 0. So you see, half plus negative half. When x equal to 0, you have a point here, and when x equal to somewhere like here, then you have, for example, 3 by 4 and 1 by 4, so it should be half, and for distance like this it will be negative half, and then for this one it will be just like here, maybe here. So the graph of sine hyperbolic x will look like this. So this one is the graph of y equal hyperbolic sine of x, and it's an asymptote, curvilinear asymptote. These two lines makes curvilinear asymptote. So similarly, you can graph y equal to 10 hyperbolic x by just dividing sine hyperbolic x equal 10 hyperbolic x sine hyperbolic x divided by cosine hyperbolic x. So when x equal to 0, sine hyperbolic x 0 and cosine hyperbolic x 1. So 0 divided by 1, which will be 0, and when x equal somewhere here, then you can also divide this result divided by this result. So it will be less than 1. You see, the numerator will be like this, and denominator will be, if it is, for example, let us say half, it will be 1.2 or something. So it's less than 1. So you will get a point like this here. For another point, you will get another point here. So the graph of y equal 10 hyperbolic x, you can graph point by point, and it also form an asymptotic behavior with the line y equal to 1 and y equal to negative 1. So for this function y equal to sine hyperbolic x, domain will be negative infinity to infinity, and the range of this function will be again negative infinity to positive infinity. But for 10 hyperbolic 1, the domain will be negative infinity to infinity, but the range should not cross negative 1 to positive 1. So the range will be negative 1 to 1, and it should be also an open interval. Okay, so you can try to sketch graph for other trigonometric hyperbolic functions like y equal to cotangent of x, y equal to cosec hyperbolic of x, and y equal to cot hyperbolic of x. So now let us try to understand some hyperbolic identities or formula. The first one, usually we need to use this formula at the middle of problems when you are trying to solve a problems. For let's say formula 1, cosine hyperbolic cosine square x minus hyperbolic sine square x equal to 1. In case of trigonometric function, we know cos square theta plus sine square theta equal to 1 plus but here in case of hyperbolic function, this one when it is minus, the answer will be 1, and in case of normal trigonometric function, we know sec square theta equal 1 plus tan square theta, plus here sec hyperbolic square theta equal 1 minus sin tan hyperbolic square theta. And in case of normal trigonometric function, cosec square x equal to 1 plus cot square, but here cosec hyperbolic square x equal cot hyperbolic square x minus 1. And other formula you can try to just remember if in case you need it. Let's have a look here again. Cos hyperbolic x plus sine hyperbolic x equal to the power x, negative x, and negative 1 will be e to the power negative x, and cos hyperbolic is an even function, so if you replace minus x, then it will be x, but this one odd function, if you replace x by minus x, then minus x will come out from here. So sine hyperbolic minus x equal minus sine hyperbolic x. And there are other trigonometric functions for hyperbolic case, and 8, 9, 10, 11, you see when the sign is plus, both of them will be plus. When the sign is minus, x minus y, then both of them will be negative sign. And in case of sine, you have sine cos, cos sine. You see, in case of sine, sine cos, cos sine. But in case of cosine hyperbolic x, there is no mix, cos cos sine sine, and here cos cos sine sine. And sine hyperbolic 2x is equal to sine hyperbolic x, cosine hyperbolic x is just like sine 2 theta equal to sine theta cos theta. And this one cosine hyperbolic 2x equal cosine hyperbolic square x plus sine hyperbolic square x. But normal trigonometric case, this one is negative, and from here you can convert it like cos hyperbolic 2x equal to sine hyperbolic square x plus 1, and which is equal to cosine hyperbolic x minus 1. Now let us try to prove formula 1, which is equal, we know, e to the power x plus e to the power minus x by 2 whole square minus e to the power x minus e to the power minus x by 2 squared. This equal, if you square e to the power x plus e to the power minus x square, then it will be e to the power 2x plus 2 e to the power x times e to the power minus x plus e to the power minus 2x, because e to the power x whole square equal e to the power 2x divided by 4 minus 4 e to the power 2x minus 2 e to the power x e to the power minus x plus e to the power minus 2x. This equal, the LCM will be 4, and if you add, if you subtract this one from this one, you see e to the power 2x plus 2 e to the power x e to the power minus x, you can cancel, like e to the power x times e to the power minus x equal e to the power x times 1 by e to the power x, which is equal 1. So here you have only 2 plus e to the power minus 2x minus e to the power 2x, and because of this minus, this one will be plus 2 minus e to the power minus 2x. So you can write, you can cancel this one and this one, e to the power 2x plus and minus, and you can cancel again this one and this one. So you have 4 in the numerator, and in the denominator you have 4, which is equal 1, which is equal right hand side. So that's the end of this lecture regarding hyperbolic functions, and in our next lecture, lecture 7, will be on hyperbolic derivatives, hyperbolic integration, and how can we use hyperbolic functions on hanging cables. Hope you enjoy the lecture, and see you in the next lecture. Thank you very much.